Hi guys, this is Craig Robertson with Innovation Plaza at UNM. We're located in the ECE building, the Electrical and Computer Engineering building. And I'd like to give you a little bit of an overview in Maxterms. Here at UNM, this can be a confusing topic in ECE 238. And I just want to kind of dispel some of the rumors of what Maxterms actually are and how they differ from minterms, and I think that this will actually help you out a little bit. So let's go ahead and start out with a basic table, just a 3-variable table, and I'll go ahead and call my inputs. Marker's running out. Switch over to this one. So let's go ahead and call our inputs A, B, and C. And then I'll call our outputs F. And what I want to do here is I'm going to set it up like it's just a normal truth table, and then I'll just label the max terms in the F column here. So let's set it up like we usually do. 0, 0, 0, 0. No, so that's 4 zeros, followed by 4 ones, and then 2 zeros, followed by 2 ones, followed by 2 zeros, followed by 2 ones. If you get this little pattern down of how to set it up, it makes setting up your truth tables a lot faster. So just work on that. You'll have plenty of practice, trust me. Now, since I've set up my truth table properly, these max terms should be pretty easy to find. And all a max term is capital M. Notice how min terms are lowercase m's. Max terms are capital M's. So all it is capital M, and it's going to have a subscript after it for the decimal representation of your binary number input. So let's go ahead and do the first one. Let's do 0, 0, 0. That's going to be our binary number, with this being the most significant bit and this being the least significant bit. So 0, 0, 0 in binary translates to a decimal 0, right? So now we can call this first row here, this is our max term 0. And all this is doing is it's letting us label and map what our outputs are for a truth table. This will come in handy when I show you how to do the K-map. So let's go ahead and do this next row. 0, 0, 1. And that translates to a max term. The decimal equivalent of 0, 0, 1 is a decimal 1, right? So that translates to a max term of 1. Let's do this next one. 0, 1, 0. If you do the binary translation, you know, this is the 2 to the 1's place, and this is 2 to 0, this is 2 to 2. So that translates to a max term of 2. Do you see how we're really just the max term subscript is the decimal representation of the binary number? Let's do one more just to make sure that you get it. It's a 0, 1, 1. This translates to the decimal equivalent of this binary number right here is 3, max term 3. Now I think you guys are seeing kind of a pattern here, 0, 1, 2, 3. That pattern does hold, so I'll go ahead and fill in the rest of the table as not to bore you. Max term 4, max term 5, max term 6, and max term 7. See how this is a 3-bit number? That means that we have 8 possible combinations. And now we're going to 0 through 7. That looks like 8 possible combinations to me. Now let me show you how to move it over into a K-map. K-maps are just a graphical way of expressing a truth table like this. So this is table form. A lot of people think better in table form. But when you're simplifying, I find that it's better to use a graphical representation. That's not to say that you have to use this graphical representation of the K-map, but I find that it's easier to simplify an equation and much faster if I'm just working from, say, a list of minterms. So let's go ahead and call this F up here, and I'll call this A, and then I'll call this B, and I'll call this C. Now some people get all hung up here because they think that max terms are somehow different from the min-term way of doing things. And it's just not the case. There's absolutely no reason why you should treat max terms or min terms any differently, except for with max terms, you're chasing the zeros, and the min terms, you're chasing the ones when you're simplifying. But we'll get into that with the K-map simplification, sum of products and products of sums. Don't worry about that just yet. Let's just worry about mapping our max terms from our table to our K-map. So let's go ahead and map this first one. If A is 0, B is 0, and C is 0, do you see how these correspond? B being the first number and C being the second number. So if A is 0, B is 0, and C is 0, and I'm going to go ahead and map that over to my table. 0, 0, 0. That means that this box right here is max term 0. You see how I've done that? Let's do another one. If A is 0, B is 0, and C is 1, let's go ahead and map that over to our truth table. We're looking for 0, 0, 1 for the input. 0, 0, 1. This would be max term 1. So you see how the max terms, they just, what I'm doing is I'm saying, alright, if there's a 1 or a 0 here for the output given by my equation, then that 1 or 0 will go here. You see how it's just like an organized way of representing things in a table or in a graph. So let's go ahead and do another. 0, 1, 1. Now this is where a lot of people mess up. Do you see how I've labeled my K-map in kind of a backwards order? It's a 0, 0, 0, 1, 1, 1, 1, 0. So I've essentially labeled this column, let's see, that's 0, that's 1, that's 3, and that's 2. We do that because we have to follow gray code. It makes simplification much easier when we're actually simplifying an equation. If you label it just 0, 1, 2, 3, you're going to come up with a nonsense equation, and it's going to be bad. You're going to lose points. So don't do that. It's you'll see more of this in the intro to K-map video. So make sure to label it like this using binary gray code 0, 1, 3, 2. Now that'll mess up kind of our organization with the max terms. That's fine. We just need to pay special attention to it. So 0, 1, 1. 0, 1, 1. Do you see how that's max term 3? A lot of people get in a hurry, put max term 2 right there, and just go all the way down to it. It's bad news. Don't do that. It's that'll lose you points for sure. So let's go and do this next one. 0, 1, 0. 0, 1, 0. See how that's max term 2. So we're going to label that one max term 2. Now let's go to the next column. A is a 1 now. So 1, 0, 0. 1, 0, 0. That means that this one right here, max term 4. Now 1, 0, 1. 1, 0, 1. That would be max term 5. You see how this is, you'll be labeling these lightning fast by the end of the class. It's a little slow to start out with. I'm going to take my time and make sure you guys get it. So let's go to 1, 1, 1. Notice that this is our strange column. So 1, 1, 1. That's max term 7. And then 1, 1, 0. 1, 1, 0. See how that's max term 6. So what we've done here is we've labeled and kind of mapped the similarities between our truth table and our K-map. So you see how wherever these terms are, that's where they're going to correspond in a K-map. It's two ways of saying exactly the same thing. This is just in a table form, and this is in a graphical form. And this way may be easier for some of you. This way may be easier for some of you. But either way, they're both very helpful tools in solving a problem, and I hope it helps you out in your studies in the future. Again, I'm Craig Robertson with Innovation Plaza at UNM in the Electrical and Computer Engineering building. Come by and see us if you have questions, not just on logic. We do circuits, we do all kinds of electrical engineering courses, so just come by and see us if you want some help or if you just want to build something. Good luck with your studies, guys, and have fun out there.